Spice Math. That's right. We add it up, multiply it, man. Spice Math. Okay. A couple things we're gonna learn today. Spice Math. All right. Take some time, educate yourself. Spice Math. That's right. You won't believe it's just math. Come on.
Hi, I'm Ruth Doughton.
Hi, I'm Aaron Williams.
Hi, I'm Brandon Alexander.
Hi, I'm Kelvin Doughton.
Hello, I'm Lyndon Sincere.
We are your Spice Math tutors.
You won't believe it's just math. Just math.
Hello Math Warriors, and welcome to another episode of Spice Math. I am Marvin Phillip, your Spice Math tutor for today. Today our topic is sequences, and this lesson is geared towards students of Form 3 to Form 5. The objectives would be for you to be able to identify patterns in sequences and to use these patterns to determine subsequent terms. To complete this lesson today, you would have to know what an intersection is. An intersection is a point where two lines meet. Here are two examples illustrating where the intersecting point is. I have a straight line coming this way and another straight line coming this way. The point where the two lines meet is where I call the intersection. Now, this example shows two straight lines, but what about if I have a straight line and a curved line? Now, the definition still stands because where these two lines meet, I call the intersection. The big question again today, make a wild guess. If you guessed this, you're correct. Because the question is, what is the pattern? We have to spend time to identify patterns in sequence questions. Today's source: Tick and Tock make circles using wires. They decided to create patterns by joining the circles as shown below. Initially, Tick took his wire and he bent it to form the first circle, which is illustrated in the first pattern here. Tock realized how much fun Tick was having, and Tock decided he's going to bend his wire to form a circle as well. When Tock bent his wire, they decided to put the circles together to form what is illustrated in the second pattern. Now we must note that in this second pattern, we see that lines meet at 2 points, and these 2 points we call 2 points of intersection. Tick wanted to bend another wire to form a third circle. So he took his wire, he bent it, he formed a circle, and he decided to put it together with the two circles that were already existing, which is illustrated in the third pattern. If we look closely, lines meet at 1, 2, 3, 4 points. Therefore, we find that there are 4 points of intersection in this third pattern. Tick decided that let us end this because we've had enough fun for the day. But Tock said, no, you bend 2 wires, I want to bend 2 as well. So Tock decided to bend a 4th wire to form a 4th circle. Can you draw the pattern that will be formed when Tock places his 4th circle along with the first 3? Give it a try. How did your pattern look? Let's take a look at how mine looked. This is a pattern that I got when Tock took his 4th circle and put it together with the first 3 circles. Now let us look at this closely. We realize that lines meet at 1, 2, 3, 4, 5, 6 places. Therefore, there are 6 points of intersection in this fourth pattern. Let us spend some time to identify the relationship between the number of circles and the number of intersections formed. The table here gives us the first set of values that represents the number of circles and the corresponding number of intersections. Now, if we recall, when Tick bent his first wire and formed his circle, there was one circle, but then when we looked here, there were no points of intersection. And Tuck wanted to join in on the fun. So along with Tick's first circle, Tuck bent his wire and put the circles together. In looking at this second pattern, there were two circles and there were 2 points of intersection with these two circles. Tick wanted to continue. So along with Tick's first circle, Tuck's first circle, Tick bent his wire and he put his second circle together with the first two. So now there are 3 circles together. And if you look closely, just erasing the little glitches just to avoid your confusion, there are 1, 2, 3, 4 points of intersection. Now, when you drew your pattern, we had Tick's first circle, Tuck's first circle, Tick's second circle, and Tuck wanted to draw his second circle. Not draw, sorry, bend the wire and form his second circle and put it together. Now, if we look closely at this fourth pattern, how many points of intersection did we identify? We found 1, 2, 3, 4, 5, 6 points of intersection. So the first question, which asked us, can you determine the value of n? Within the table, we see that n represents the number of intersections for the 4 circles. So we can conclude that the value of n, or n, would be equal to 6. Now for the second part of the question. We want to write down an expression for y in terms of x, where y is the number of intersections and x is the number of circles. How are we going to do that? So now we want to write down an expression for y in terms of x, where y is the number of intersections and x is the number of circles. How can we derive that expression? First of all, we must identify the pattern or the mathematical rule that governs the number of intersections compared to the number of circles. Let us try to create something and test it to see if it works for the first pattern, the second, the third. We could also test it for the fourth, and then we can conclude that it's going to work for when we have x number of circles. But we recall, we found that n is equal to 6. When we had 4 circles, we had 6 points of intersection. So we're going to try to identify a mathematical rule that will tell us the number of intersections based on the number of circles. Let's try it out. So some persons may identify a pattern that as I increase the number of circles by 1, then the number of intersections increases by 2. So when I had 1 circle, 0 intersections, 2 circles, 2 intersections, 3 circles, 4 intersections, 4, 6 intersections. Now, if let's say we are thinking about having 5 circles, Now remember that x represents the number of circles, so I'll write it here, and y represents the corresponding number of intersections. So if we think, let's say I had 5 circles, then how many intersections do you think we would have? Yes, 8 intersections. But if, for instance, I asked you to determine the number of intersections if I had 100 circles put together as illustrated in the patterns, would you take the time to draw or to count in twos to get the 100 circles? No, I think that may be a bit impractical. So it would be more practical for us to identify a mathematical rule that would find the number of intersections based on the number of circles. And that is what we intend to do with question 2. Now here we must remember our input is x. Now we have to figure out, what am I going to do to x that is going to give me whatever y is. So in the first instance, as I am dealing with one circle as given here, now what can I do to x that would give me y? So in this case, x would be 1. So what can I do to 1 to give me 0? We may say first, let's subtract 1. So x being 1, 1 minus 1 gives me 0. It works for the first pattern. Now we have to test it for the second. So when we have 2 circles now, x in this case would be 2. 2 minus 1 gives me 1. And 1 is not what is given in the table here, which is 2. So we'll have, clearly this rule will not work, but we can adjust it to suit. Now, we may say, okay, I can leave the 1, but if I have 2x. Now, in the first instance, I have 1 circle. 2 times 1 minus 1. 2 1s are 2. 2 minus 1 does not give me 0. But I want to get 0. So how about maybe subtracting 2 from it? When I subtract 2, it gives me 0. Maybe this rule works. So we'd have to first of all test it for the others before we conclude that it does indeed work. So I would test it for 2 circles. 2, now in this case x would be 2, so 2 times 2 minus 2. 2 2s are 4, 4 minus 2 gives me 2. It works for the second pattern. How about the third? 3 circles. 2 times 3 minus 2. 2 3s are 6. 6 minus 2 gives me 4. So I realize that my rule is working. If you test it for 4 circles, I can guarantee that you will get 6 points of intersections. And if you test it for 5 circles, I guarantee again that you'll get 8 points of intersections. So the expression for y in terms of x would be 2x minus 2. Please remember that this method is what we call trial and error. You have to sweat, try, test, and prove that it works. This brings us to the end of this episode of Spice Math. I hope you learned a lot. I hope you enjoyed yourself with me. See you next time.
You won't believe it's just math. Come on. You won't believe it's just math.